give them a welcome.
Okay, so hello everyone, I'm Yoel, this is John, and this is Rana, and today we will be talking about our robot toy Pomelo, and mainly about how we came up with the idea, how it works, and the procedure of us making the robot itself. So, to talk about how we came up with the idea, a little bit of background about ourselves. We work in an environment where we have to stay after school because we're high school students to work on our projects and develop things. And there we use peer learning and trial and error to actually make our projects come to life and learn how to program and all of that. And as we were discussing as a group of friends, we figured out that we should enhance this type of learning to a larger group of people. So we came up with the idea of creating an organization called Coding Summit, which has been going on for 6 years now, where students our age who know certain types of programming languages or electronics teach other people from all ages how to code. For example, I do Arduino, John does Fusion 360, and Rana does iOS software development. And as we were doing, giving our classes to other people, we realized that most people lack the understanding how a program works. For example, when they're given a certain task, they can't just start from point A and get to point B, and it kind of damages the process of the learning. And because of this, we decided to create something for especially younger ages to understand how algorithmic procedures work. So we came up with the idea of creating a robot called Pomelo. And what is Pomelo? Pomelo is an interactive education robot specifically for programming, and its main usage is for ages between 4 to 7 in classroom environments. And how does it enhance these skills is basically, does this mic work? Yeah. So how it works is there's certain physical blocks that have the motion statements such as turn left, right, backwards, and forwards, and also time blocks which indicate the time of the movement. And what kids can do is stack these blocks on top of each other, one motion and one time block at a time, and then put the robot in front of it and then press the button, and then the robot does whatever the blocks tell it to do. It doesn't have its battery in, so it's not working right now. But because of with this, what we aim to do is to help children understand the basics of programming. But for it to be effective, we wanted it to be inside of a classroom where the teacher knows the abilities of their students, so they can give them specific tasks according to their abilities. For example, solving a maze. And as they're solving a maze, what's also important is that they work together to solve a specific problem as they collaborate and also improve in collaborative skills. And how that works is when they're trying to solve a problem, for example, as they're trying to figure out how to go through the maze, one of the kids says, let's move forward for this amount of time and then we can turn, and the other one says, no, we should turn first and then move for a certain amount of time and discuss and work together. So that's basically how we aim for it to work.
So we had all these ideas and we wanted to organize them in a flowchart, which we decided to handle Pomelo in 3 different aspects. One of them is the monitor, which displays the emotion of the robot. The other one is the coding blocks that Yoel just mentioned, which also indicates the movement. And the other one is the speech recognition, which answers the children's questions. So a little bit about the coding blocks and how we got here. So we decided that we could use something like QR codes for the robot to read it and then act accordingly. But when we tried out QR codes, we understood that the PyCam couldn't read the QR codes from a certain distance, and it was getting really complicated. So we did further research, finding the Urco markers, which was really a lifesaver for us. And these Urco markers had two main benefits for us. One of them was that they were very simple and the PyCam could read it from a certain distance, so it could move faster and it could detect them faster. And the other one was that Python already had a library for Urco markers in OpenCV, so it just made our coding process much easier and we got to benefit from Python's nice library. And so another aspect here is Pomelo's emotions. So by the time we got here, our Urco markers, we were satisfied with them, but we still have like a lot of time to develop them. But we thought that our robot was kind of dull and it was unfamiliar to kids. So we started searching about how to make a robot familiar and easier to interact with. And the answer we found was pretty satisfying. We decided to add expressions to the robot just like humans. So how could we do that? We decided to use the eyes as an indicator of expressions. So when a kid interacts with Pomelo, it reacts in certain types of emotions such as angry, happy, sad, and sleepy. For example, when you press the button and Pomelo doesn't read the Urco or is unable to read the Urco, it reacts with a sad emotion. And when it does read the Urco, it just reacts with a happy emotion, which makes the interaction better and more fun. And during our coding process, we used the PyWorks Turkey library, which HisRCS formed as a group, and our friends just presented that library this morning. And what this library did was it just simplified our code for the PyCam and the motors. And as we are beginners in Python, it was like a really nice process, and our code was really legible.
So this brings us to our first prototype. It was to test out the electronics, the Raspberry Pi based electronics and the code. So this didn't have any like an outer shell like this one does, and this was just made from a laser cut acrylic base and a 4x mount for the camera and the display. So with this prototype, we learned that the camera needs to be a lot higher up than it is here, since this way it could only read basically like 2 blocks at a time, and it can't read from a distance. And to go into the further prototypes, we needed to make a design, an outer shell for it, and for that we needed a design that would already have a positive image in the mind of a child. So we surveyed kids from our school's primary school department, and we showed them pictures like these. And an overwhelming majority of them picked this one to play with, since it resembled a dog, and a dog is much more positive in a child's mind than a robotic figure like this. So this design was chosen for the later prototypes. And with that, we developed our second prototype, which was just the outer shell of the robot, and it was just to see their design in real life. There was no way to put the monitor inside and the button, and there was no way to connect the 3D printed pieces, so we just used tape. This was to present the robot in a way that the child could actually pick it up and see it in the real world, and we got positive response, so we moved further with our third prototype, which had the same outer design but had these kind of pin slot designs to connect the 3D printed pieces, and a way to mount the electronics as well. This was our first functional prototype that would work with the blocks and moved accordingly. And after a few bug fixes and electronic fixes, we developed our fourth prototype with bug fixes, and we went to the student design competition in Human-Robot Interaction Conference in Daegu, Korea.
This conference was really beneficial for us because as we attended there, we had the opportunity of getting a lot of feedback from people who work in this field and know what types of things they're doing and have been researching about this in a long time. We also had the opportunity to publish our paper in the IEEE library, which you can scan the QR to access, and we'll also have an opportunity to scan it later on. And also, these are other two members who couldn't attend the conference.
With the feedback we got in the conference, we started developing our fifth prototype, which was a major design change. We added a hinge like this, where you can see the head opens like this, for us to access the Raspberry Pi and the electronics much more easily and without disassembling the whole robot, which makes the R&D much more efficient and faster. We also added rounded corners to the screen and make the feet much more prominent to make it more toy-like, so a child would be much more comfortable playing with it. But the most major upgrade was that we shrunk the design a lot for the motors to have an easier time moving it around and for the teacher to develop a smaller maze in the classroom. This is the most recent prototype we've done and we are still developing it.
So the most frequently asked question in the HRI conference was that, what is the difference between Pomelo and other educational coding platforms? Well, Pomelo here is designed for both physical interaction and collaboration amongst children, so we just thought it would be beneficial for children to participate together and learn from each other while also learning coding. Yeah, that's basically it.
So you can see a video of people playing with our third prototype here, if it opens up.
It takes a little bit of time.
So while developing this as beginners ourselves, we saw how hard it was to develop a toy robot like this, and we were really surprised to see that blocks that a child could understand so easily was really hard for a Raspberry Pi to understand. So we are continuing to developing ourselves in Python and 3D design and developing Pomelo as we go along. In the future, we plan to implement this in classroom in our schools and potentially other schools as well. We think that a toy like this could be really beneficial for a child, since thinking like a programmer isn't just useful for a programmer, but we think that it's an essential life skill in these times.
That was this talk, but also if you want to access our code, this is the GitHub link for it, and also you can access the presentation from this QR, which also has the paper as well. So we'll just leave this open here, and this is our social media.
That was incredibly impressive. You keep on referring to yourselves as beginners. You might have been at the start, but I can guarantee you're not anymore. Do we have any questions? I'll start us off. And could you tell me a little bit, I'm very interested to hear about yourselves and what each of your plans are after high school.
Well, individually.
Yeah, individually.
All right.
Or together, or whatever.
So, talking about myself, well, honestly, I want to study college abroad, but my plans for the future is I'm really into coding and iOS development, so I am planning on doing something about that, hopefully, and I also like developing games, so yeah, that's basically it.
I want to study engineering, and with that I can learn a lot more 3D design and potentially upgrade this.
Honestly, I'm not sure what I'll study, but probably something in between computer science and engineering, and yeah, that's...
Thank you. Does anyone else have any questions?
Thank you. It's really interesting to see this intersection of engineering and programming and how you've brought them together. I'm really interested to know what kind of direction you see in this and whether the most challenging things will be from the engineering side or from the software side. And not just the challenges, but will the bigger steps forward come from also the software side or the engineering side in this?
So basically in the software side, we want to add, as we said, voice recognition, and we're currently working on that with the Google API software, and we're actually just started new, and the person who is focused on that is not here, unfortunately, but we have been struggling with it a lot, so I think software-wise, that will be a major step forward for us.
I think one of the most difficult steps we have to face with this is that this needs to be implemented in the classroom. So I think doing that in different schools than ours is going to be really difficult.
Any other questions? I have another one myself. Can you think of any steps along the way that you would do differently now, or and perhaps any routes you've taken that have forced you into a position that's difficult?
Well, while we were doing this robot, we were all beginners. This was really, it improved us like majorly, but I think it would be better, and it would also spare us a little bit more time if we started learning Python a little bit more earlier after deciding making this robot, but I think it was a really good experience to learn about our mistakes and to learn about Python while making this robot, because we just experienced it like lively out there, and if anyone wants to answer.
I think with every mistake we did, we got a lot of feedback, so I think it helped us a lot ourselves. So I think I wouldn't do anything differently, so we could get the feedback and develop ourselves.
And I just want to add on to that and say that as we worked on the project, we realized more and more in every single step when we went forward that not planning ahead, like from the beginning, and just sketching out what we were going to do really affected us, because it was harder to develop something that we didn't know what the next step was going to be, and we needed to create it as we go. So that would be something that I've learned from this.
I wonder if you could say a little bit more about what it has cost you, what kind of budgets and outlays have been involved, because obviously there's equipment, maybe you're paying for services, maybe you're buying materials, and of course you're spending a lot of time in it. Do you have an idea of what the total cost of your project is? Can you flesh that out a bit?
So about time-wise, actually, we spend a lot of time for this project after school, as there's no opportunity to work it during school time. So that kind of costs us a lot of time. But budget-wise, we actually have been going on and off sponsorship meetings with different types of organizations to help us fund and make this possible. And for example, we needed to have a funding to attend the HRI conference because going to Korea is not cheap. So mostly we try to find sponsors to help us with this project, but additionally we sometimes have to pay from our own pockets. For example, I remember John ordering a lot of PLA for the 3D print, which was not cheap.
Perhaps I'll ask one final question. You mentioned it's taking a lot of your time. You're also in high school. Has there been a negative effect to this on the rest of your studies?
Well, yeah. So I think we'll all answer this individually because, well, actually the HRI conference was just before our finals. So, and during our finals, yeah. So that really paid off a lot. But I mean, I don't regret going to the conference, and I definitely don't regret any second that I spent on this project, because I think it's much more special than one final in my life, and I'm gonna remember this forever, where else I'm never gonna remember my finals. So, yeah.
Well, one thing I can add on to that is, I think for this last year, I haven't had a nice amount of sleep for so long as we were working on this project. And because we would just stay at school for so long and work on it for so long, we even had a day where we just were trying to find a document which ended up in my junk mail for 2 days straight, which was kind of disappointing.
Great, well, thank you. I think we'll stop the questions there, and good luck with the rest of your studies, and thank you very much for a very impressive talk.
Thank you so much.
I'm actually, sorry, I work at the university, I'm a mathematician at the university. I can give you my contact details.
Actually, that would be
If I can ever offer any advice or any other help or anything.
Thank you, that was so interesting.
Thank you for coming.
Thank you for coming. I'm going to follow you on Twitter.
So, unfortunately, most of the electronics
Yeah, I know it's not
are
working, but what kind of
So I can,
wheels or
so I can show you a little bit. So here's the button that it presses, and there it is. John
Some of the
Monson.
other Turkish attendees here who are involved.
so you have one wheel here and
And the one with
two
another
wheels.
wheel here, and then we have two DC motors, which are controlled by the Pomelo drive.
Yes.
The shield,
Okay,
motor
good.
shield.
So maybe
We also have a PyCam over here, which we
Nice.
use to detect QR codes. And also we have a button here, which is the button that we can press for the camera to read, start trying to read these.
And that's your battery connector.
Yeah, that's our battery connector.
But
Unfortunately, the camera burned out, so
okay.
it doesn't work. So that's why we couldn't showcase it.
And during shipping, they usually searched it.
Yeah.
And it damaged it.
They searched it to that.
I just wanted to say thank you for the talk. It was very, very interesting, and the stuff that you've done, it's really cool. I was thinking, did you consider, putting the, open hardware project, where you put the parts of like other schools in other universities, so in
Yeah, so
other
they can
countries,
work on
they
it.
can,
Yeah.
3D print and keep this going, or like test it to the next level.
We were just talking about that, like as we were coming over here. So we're planning on having both like an explanation of how the electronics are supposed to be, and also like a schematics, and also as you said, the STLs of the 3D design, so anyone can just print it out anywhere in the world. So it would be open source.
It's
Yeah,
like
the code is in our GitHub, and after putting like all the attachment mechanism, and when the prototype resembles a final product, they'll publish the STLs as well.
it's what you've done. It's very impressive. Like when I think it's hard to realize, but all the you know, when you reach the stage, like people go to universities, learn all this stuff, but they don't realize that they could have done all this much younger. Like what you've done is the equivalent of, when companies hire, the graduates, they cannot get from this level, from the idea to, you know, implementation. So what you've done is more than what people get taught in university. I just wanted to say that all those sleepless nights, it's, trust me, once you go to employee, it's like you already managed to do it and you can think on your feet, you know, because the most important skill is that you don't complain, you just go and figure out how to do it.
Yeah.
And this is so invaluable. It doesn't matter that you studied at Harvard, but oh, you can do it. It's okay, you are hired. It's like,
As someone who helped produce those graduates, I completely 100%
someone who is on the opposite side trying to find someone who can think. It's very impressive, and I can say that, you know, you are ahead of the curve. So congratulations on that.
Thank you. We're like really lucky about that because our teachers and the
Are you the teacher?
Yeah.
Congratulations,
Yeah.
you two should be
And
very
the
proud.
school, exactly. And the school really supports us on like learning and working on our own and trying to understand everything, and they just give a lot of their time and just spend extra time with us, which is really great.
And when you mentioned you are the beginners, trust me.
Yeah.
Everyone is a beginner. It's like, you know, you get to the senior position, but still the code that you're doing probably is similar to yours because you're, especially in Python, you're just making things work, so you're a lot of the beginners, but even compiling the libraries and making them accessible, it's very impressive. Congratulations.
Thank you so much.
Thank you.
very much.
Thank you.
And our students have followed you, and you and I spoke on Slack as well. So,
Oh, yeah,
So
of
if you
course.
need to get in touch with you.
Yeah, I'll get in touch by Slack
Please
because
do.
we use it a lot. If it's okay by you.
Yeah, please do.
Okay,
Yeah,
that's
so,
perfect.
Yeah.
Thank you.
My Twitter handle, I'll give you my Twitter handle. I guess that's a good place to start. You can